Trig 2, getting into the fun stuff. So here we go. We'll start with a warm-up, and I just want to go onto the Cartesian plane, but in a very safe way. So find the angle made by a terminal arm passing through the point 4, 5. So we're going to count for our x value, which is the 4xy, over 4 here, and we're going to count up 5 for y here, and wherever those intersect, that's where my terminal arm passes through. Woo! Should have been a straight line, definitely isn't. And this is my angle that I'm concerned about. So the minute I do that, this is a bit of a review, I've made a right triangle, and I've made this right triangle, where I have a height of 5 and a base of 4, and those correspond to sitting at angle theta, an opposite side, an adjacent side. And I remember, if I think back to Casa-Toa, that if I want to find an angle, I know that tan of my angle should be equal to opposite over adjacent, which equals 5 over 4. So if I want to get the actual angle, I use that arctan inverse, and when I punch that into my calculator, I get an angle of 51.3 degrees. So if we go on to the Cartesian plane full bore, like if we add in the negative x and the negative y, we get a little graph that looks like this. And we're going to talk about standard position, which for our purposes is how we're going to measure all of our angles. So no getting fancy. So we're always going to start with 0 degrees on the positive x-axis. And if we want to make a positive angle, we're going to rotate through counterclockwise. So 90 degrees is at the top at north, 180 is in the west, let's say, and 270 is to the south. And that's how we do it, especially North American style. So we're gonna roll with that for the purpose of this unit and the vectors unit. Okay, so if we're gonna start here, every time I spin this way, I make a positive angle. So if I have some kind of terminal arm shooting up like this, let's say, and I want to make a positive angle, I start at 0, I rotate through. And maybe this is 60 degrees. Okay, let's draw another one. If I want to make a different angle, let's put it over here. And if I wanted to know that positive angle, I would start at 0, and I'd rotate through 90, through 180, and maybe that'd be about 210 degrees as a positive angle. And if I wanted to think about negative angles, I would start, let's put one here. And if I wanted to measure it as a negative angle instead of a positive angle, I'd still start at 0, but I rotate clockwise. And then that makes the negative angle minus 45. Okay, so there's some measurements. Now, let's look about other ways to identify these angles. So let's look at our negative angle first. Our negative angle is minus 45, but we could have also measured it starting from 0 and going around in a positive way. So another name for that, negative 45 degrees, it's also the same as positive 315 degrees. And we call those angles coterminal. Okay, and if you ever want to find multiple coterminal angles, you can do that first thing where you find the negative and the positive. And then if you want to make more coterminal angles, you're just going to spin around another 360. If I'm sitting there with my negative 45, and I wanted to measure another positive angle or another negative angle, let's say, that's probably easier. If I start and I go right past it, and I rotate all the way around, I can have an angle that's negative 45, subtract another 360, which makes negative 405 degrees. That is also coterminal with negative 45 and 315. We're going to look at quadrants and what they are, and they're just kind of defined by the x and y axis. So if we have 0 here, 90, 180, 270, and if we spun around to 0, it would be 360 would be back at 0. We have something we call quadrant 1, which is between 0 and 90. Quadrant 2, 90 to 180. Quadrant 3, 180 to 270. And quadrant 4, 270 to 360, or back to 0. There we go. So sometimes you might be asked to find in what quadrant a certain angle lays. So if I have angle 302, well, I know I'm going to go past 90, past 180, past 270, And then, you know, now I'm just kind of eyeballing it. Could be right about here. So that's angle 302. And it happens to be in quadrant 4. Likewise, for angle 197, I start here. I go past 90, past 180, just a little past 180, another 17 degrees, and I'm going to get 197. And I'm going to see that it lands in quadrant 3. Okay, and then now let's do a negative angle. I'm going to use pink, which will look too much like red, but we'll try it. Okay, so we're starting at 0, but we're spinning clockwise, past negative 90, past negative 180, past negative 270, and a very little bit more, another 5 degrees, to make negative 275. And that one actually ends up in quadrant 1. So just knowing those quadrants and how you tell where angles are going to get. Now the second thing they're asking us, can we find coterminal angles for all of these things? So how do we do that? Well, the easiest way to do it, 302 minus 360, 302 plus 360. And when I do that, every time you're going to get coterminal angles. So you could have, 662 goes here. And here we could have minus 58. Okay, and same thing, 197 plus 360, 557 is coterminal. It's in the same location. 197 minus 360, negative 163 degrees. Same thing, negative 275 minus 360, and negative 275 plus 360 is 85. And that's the clearest one to see it. We knew it was negative 275, but if we go this way, the positive angle that is coterminal is 85. Since we're hanging out on the Cartesian plane now, we're going to start redefining or calling our sides different things. So, and I always want you to build triangles from the x-axis, no matter where you end up building it. So maybe you can have a triangle that you're going to build from a terminal arm. The easy one is, you know, our standard one. But we could also have one in this quadrant built from there. We could have one in, let's say, this quadrant built from here, or even another one in this quadrant. And every time we do these ones, we're going to have sides like this. So these are our little right triangles in different positions. Put that guy back, and put that guy back. And then every time we have an angle, I'm going to put we draw it between the terminal arm and the x-axis, be it the negative or positive axis. And if you do that, you're going to set up a situation where if theta is always there, then your opposite side will always be the same as the y. So we're going to start thinking of the opposite is now y. Okay? And if we the adjacent side, it's always going to run along adjacent to that angle, theta. It's always going to run on the x-axis, be it positive or negative. So it's always going to have a name now that is x. And we're going to call the hypotenuse r, just because we are. So we have now, instead of having c squared equals a squared plus b squared, we can use something like r squared equals x squared plus y squared. And our new ratios are going to become, sine before was opposite over hypotenuse, but now let's start thinking about it as y over r. Cosine before was adjacent over hypotenuse, but let's start thinking it more as x over r. And tangent was opposite over adjacent, so let's start thinking of it as y over x. So now that we've got x and y taking the place of adjacent and opposite respectively, we've got to really think about what's going to happen with our cosine and our tangent and our sine now that we're doing this. So let's go to our Cartesian plane and label our quadrants. We have 1, 2, 3, and 4. So I really want to think about what is happening in each quadrant. If I'm in quadrant 1, that means all of my x values are positive and all of my y values are positive. X is positive, y is positive. So if I look at my ratios, let's say sine y over r, cos x over r, and tan y over x, because all of my inputs are positive, and we're going to say that r is always going to be positive, that's just something we're going to take, we have all of these ratios being positive. Now if I move into quadrant 2, y remains positive, but x is negative here. I'm on this band of the x-axis, which is where all the negatives happen. So I think about sine, cosine, and tangent. And suddenly, using different colors all the time, y over r is positive, but x over r is negative, and y over x is positive or negative, which is negative as well. Okay, moving into quadrant 3, both of them, x and y, are in the negative realm. So I'm in a situation where I have x negative and y negative. So I think of my ratios, y over r, x over r, and y over x. Using another color. Negative over positive, so this is negative. Likewise, negative over positive is negative. And negative over negative makes the y over x ratio, the tangent ratio, positive. And moving into our quadrant 4, x goes back to being positive, y remains negative. So our three ratios, we are going to get y over r is negative, x over r is positive, and y over x is negative. So this is just setting us up for our next slide. Welcome to the cast rule, and the cast rule is just how we keep track of everything we just decided. What it tells you is in what quadrants each trig ratio is positive. So it's identifying positive quadrants for a certain trig ratio. So we start, unfortunately, cast starts in quadrant 4. So if it's easier to remember it as like all-star trig class to keep it through 1 through 4, that's fine. Otherwise, remember that when you write down your CAST, your cast, you start it down here. Okay, all that means is A stands for all. So that means in quadrant 1, the cosine and the sine and the tangent of any angle between 0 and 90 will all be positive. Okay. S is for sine. So in quadrant 2, between 90 and 180 degrees, you will have a sine ratio that is positive. However, cosine and tangent will be negative. T stands for tangent. So in quadrant 3, which is between 180 and 270, you're going to have a positive tangent ratio, whereas sine and cosine will be negative. And C, of course, is cosine. And that means in quadrant 4, you're going to have a positive cosine, and the other two ratios will be negative. To think about the secondary ratios, or the reciprocal ratios rather, not the primaries, whatever you call them, they're going to behave the same way their partner does. So sine goes with cosecant. So cosecant will be positive here, okay? Because if sine is y over r, cosecant is r over y, and those are the same two inputs, so you have to have the same sign. And then likewise, cotangent will be positive in the tangent one, and secant will be positive in the cosine quadrant. So, and they will all be positive in the all thing. Now the big question is, why am I making you do this? And this is a hard one to get into without getting into trig graphs too much, but I do want to speak about what trig graphs look like and why this happens. So I'm just going to draw a sine wave, and we're not going to do graphing, but what you need to know is that when you graph a trig function, they are periodic, they repeat, and they're nice and undulating, and it goes through one cycle normally between 0 and 360. So this is sine. Okay, so when we think about our coterminal angles, so at some point, this goes between 0 and 1 and 0 and -1. At some point, we hit a certain value, right? Let's say that's 30 degrees, okay? And 30 degrees has a sine of 0.5. then when you get over to a coterminal angle, 390, you're going to hit that 0.5 again, and so on and so forth. However, if you look at the graph, between 0 and 360, yeah, I hit that 0.5 here, but I also hit it on the way down as I spin around that circle. So there's a second angle that has a sine value of 0.5. And our problem is that our calculators, if you were to press sine -1, 0.5, it will only ever return the angle closest to 0. It won't go find other angles for you, okay? The coterminals are easy. We already said that up top. But yeah, there's usually, except for if you're at a certain points like this one or this one, two angles that would have the same sine value. So this is the same height as that. That's the same sine value. You need to find the one that your calculator will give you, which will be the one closest to 0, which will be that. But you need to find the second one somehow. This is why we're doing all this. So let's go through the process of finding multiple angles. So our first step, and I want you to do it step by step. If you're good at this, that's fine, but this is how I tell people how to do it. Okay, so we're going to start, before we do any math, we're going to look at what we're given. We're given a sine ratio, and we're told that it's equal to a number that is positive. So basically, I'm looking for sine, and I'm looking for where it's positive. So I go over, and I just want you to check off where sine can be positive. So here and here, you can have a positive sine value, and that's just using the cast rule, okay? Which means that I'm going to have two angles. One of them will be in quadrant 1, and one of them will be in quadrant 2. Two answers. Our next step is to find the reference angle, which I use the symbol B for beta for, okay? Often this will end up being one of your answers, but for now, we're just going to pretend that it isn't. So when we look at this, let's take an example where we were given cosine of theta equals negative 0.324. This is what we were given. So if I want to find the reference angle, you're going to drop the negative. You're going to use the absolute value, so you're always going to use a positive number. So you're just going to use the same ratio that you were given, take the inverse of that number. Okay, so for our example that we started already, we had sine theta equals 0.345. So if I want the reference angle, inverse sine, it's already positive, so it goes exactly in, and that's going to return a number approximately equal to 20 degrees. What that reference angle is going to tell us is 4 possible locations for our two angles. And the deal is that you use this kind of bow tie trick, and it will tell you, no matter what the angles were, if they are the same, all of your reference angles will be relative to the x-axis. So never go here relative to y. Okay? So you're always going to be measuring here, 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 and here. Okay? And each of those will have the same reference. So what have I created? I've created 4 distinct angles. Here's one, 20 degrees, which is possible. Here's another one, 180 degrees, subtract 20, 160. Okay, so if it's in quadrant 2, that's always going to be the math you do. Here's a third possibility, standard position, 180 plus another 20 degrees, or 200. And our fourth possibility, starting from 0 because we're using standard position, is going to be 360 subtract 20, or 340. So these are all possible values of an angle that could have an absolute value of that sine theta is 0.345. Which ones do we want? We go back to step 1 and we remember where our angle could be. Our angle was in quadrant 1 or quadrant 2. So the angles that I'm looking for are this angle and that angle. And we have that B value The reference angle is always this kind of piece, the acute angle from the x-axis. So I know that theta 1 is my easy one, which is just the same as the reference angle, equals 20 degrees. Theta 2, my second angle with the same sine value, is in quadrant 2, which means it's going to be 180. Subtract that 20 degrees, which means 160 degrees. So my answers for this question are 160 and 20. So check your answer. The beauty of this trig stuff is you've got the calculator there. It can tell you whether you're right or wrong. So I'm going to take my 20 and my 160 degrees, and I'm going to find out what the sine of both of those are. And I should get approximately 0.345. We rounded, so if you get 0.341 or something like that, that's fine, okay? You've done things right. Now, if I get the number from the question, but the wrong sign, like if you punch it into your calculator and you get negative 3.45, then you've accidentally picked quadrant 3 or 4. So you've done that, and that will be the 200 we said, and the 340 will give you those values. And just always thinking, because those 4 triangles you make with the reference angle, the minute you made the reference angle the same, those are 4 congruent identical triangles, okay? So those ratios have to be the same. The only thing you change for 3 or 4 is that you made the y negative, and that made your sine ratio negative. And the other possibility of things that could happen is you get a totally different number than this when you punch it in. That means you either picked the wrong reference angle or you made a math error somewhere along the lines. We're going to look at a few examples, and we're going to go through those steps every way. So we're looking at cosine. So step 1 is find out where the angle can be. I have a cosine, and it's negative. And here's my thing. So I know where this tells me, this cast rule tells me where cosine can be positive, which would normally be quadrant 1 or quadrant 4. But if I'm looking for negative cosine, it's where it's not positive. So I'm going to check mark quadrant 2 and quadrant 3. Okay, the next step I'm going to do is I'm going to find that reference angle. I'm going to use the same ratio, inverse ratio, but I'm going to use an absolute value, the positive. When I do that, I'm going to get a reference angle, and that's just punched into your calculator, equals 83 degrees. So I go back over to my thing, little Cartesian plane here, and I know that one of the angles could be here, and one of the angles could be here. And that 83 is always with respect to the x-axis. Do not start from the y-axis, or it's going to mess everything up. Okay, so my first angle in quadrant 2 will be 180 subtract 83, because I go all the way to 180 and go back 83. And my second angle will be 180 in quadrant 3 plus 83. So I'm going to get 97 degrees as one answer and 263 as my second answer. And if I check that, if I were to take something like cos 263, I go back and it gives me 0.121869, close enough, okay? Like I said, rounding really changes the values in these trig things. Example 2. Okay, so we now have tan that is positive. So let's start by drawing our little picture. Right, I've got papers rustling all over the place in the background here. Cast, and I want positive tan. So it can happen here in the T quadrant or in the A quadrant. Next step, find your reference angle. Use the same trig ratio and a positive number. And when I punch that one in, it gives me 67 degrees. Okay, so I go back and look at where I need to be. I need to be in quadrant 1. So in quadrant 1, your reference angle is your actual angle, so that's easy. So one angle is 67. My second angle is in quadrant 3, so I'm going through 180, and then I'm adding that extra 67 degrees. And you're going to get get 247 degrees as your second angle. So those are your two answers. Heading to a third example of the same thing, I'm going to draw my cast even before I look at the question, and I'm going to see that I'm looking at cosecant. Okay, cosecant goes with sine. And when cosecant is negative, sine is negative. So I need the quadrants where sine is negative. It's positive in 1 and 2, so I must be looking in 3 or 4. Okay. I need to know what the sine value is because I need that from my calculator. So I know that sine of theta is going to be the reciprocal of the cosecant. So you can just use the reciprocal button on your calculator, or you can do this math and you're going to get negative 0.883. Now I can find my reference angle. Remember, for the reference angle that you're just going to use that 0.883 as a positive, and that's going to give you 62 degrees. Okay, here we go. So my angles are, the first angle in the third quadrant is 180 plus that additional 62 equals 242. And our second angle is going to be in the fourth quadrant, so I'm going to go all the way to 360, and I'm going to subtract that 62, and I should get 298 degrees. Done and done. As we said before, if you only have like one parameter, that sine is positive or cos is negative, you're usually going to end up with two angles. Sometimes, though, we have questions where we add an additional restriction. So let's start with what we know here. Cast. And I'm going to start with this information. I have sine is negative. So that tells me if sine is negative, I know that I can be in quadrant 3 or quadrant 4. And now I have a second piece of information. Tan is greater than 0. If tan is greater than 0, that just means that tan is positive. It had said, if it had said tan, I'm just going to do an aside over here, less than 0, tan would be negative. So that's what that parameter is telling you. Okay, so we know that tan is positive. So I'm going to have a second set of checks where tan can be positive. It can be positive in quadrant 1 or quadrant 3. Now, you're going to have one angle only, and it's the angle that satisfies like all the conditions. So it has to be where you get 2 check marks. It has to be in quadrant 3. Otherwise, my steps are the same. I'm still going to find my reference angle using the positive 4.451, and I get my reference angle is going to be 27 degrees. And then I know that my angle, which looks like this, is going to be that 180 plus an additional 27 in standard position equals 207 degrees. So additional restriction, usually one angle. Here's another one. So we start with our cos issue. So I see that cos is positive, which means it can be in quadrant 4 or quadrant 1. And the second restriction I see is that sine is less than 0, which means sine is negative. So sine can be negative in quadrant 3 or quadrant 4. The place where I see both check marks is in quadrant 4, so that's where my answer will be. Now I go back. I'm going to find my reference angle using the one that has numbers. I don't have any actual values for the sine, so I can't do anything with that. So I'm going to take cos inverse of 0.512, and that gives me a reference angle, of 59 degrees. Okay, and if I want to be in the fourth quadrant, there's my thing. I go all the way to 300 and back 59, so my angle is going to be 360 minus 59. And you can do that visually, or you can just use those formulas from the other slides, and that equals 301 degrees. Check your answer. It should give you this cosine. So looking here, the question is, how can we be jerks with this? This reads like all the other things, except for they are not asking for an angle. They're asking you to find a cosine of an angle. So you're going to go through the same way as we have been, and then just add that step right at the end. So here we go. I need to have negative sign. Negative sign happens in 3 or 4. And I also need to have a condition, let's make the blue condition, where tan is negative, and tan can be negative in 2 or 4. So I know that I'm going to be in quadrant 4. Find the angle, no different, the reference angle rather, to find the actual angle. So we're going to use sine inverse using the positive. And then when you do that math, you should get something around 35 degrees. We're going to find the actual angle, which is going to be 360 subtract 35 degrees equals 325 degrees. And because we didn't want the angle, we wanted the cosine ratio of that particular angle, we do that last step, and it's just on your calculator. Punch it in, and it should return 0.819. So watch what we're asking you for. Last slide. Where can angle theta be located if I give you these two conditions? So this is saying that cosecant is negative because it's less than 0. And this is saying that secant is positive. So I don't really have much to say about the reciprocal ratios. I prefer to think about the primary ratios. So before I do anything on my cast chart, I'm going to recognize that if it's cosecant, we're talking about sine. And if it's secant, we're talking about cos. So where is sine negative and cos positive? Sine is negative in 3 and 4. Cos is positive in 1 and 4. The only quadrant that answers that question or satisfies all those requirements is quadrant 4. So in this case, all you have to answer is a quadrant. They didn't give you any numbers, so you're not going to find any exact angles. And that's all we have for Trig 2.